Good morning, everyone. Welcome to MDC 332A, building a fully automated cloud with System Center and Hyper-V. I'm Toby Alcock. This is Philip Duff. We're from C&I. What are we talking about today, Phil?
Well, I'm pretty sure everyone's here because they've heard the hype that you can take a bunch of hypervisors, put some management on top of it, and you've got a cloud. It's as simple as that. Everyone knows that, yeah? Look, there's a button up there that says Create Cloud. That's all you have to do. Easy. Well, you're probably here because you know there's a few more things than that to do to this, right? You know, you've got to do hardware management capabilities because it's great that you've got this elastic cloud, but someone's got to be plugging in servers underneath that. And you've got to do network designs, and you've got to retrofit all of this to your environment. And we've done a lot of that for a very large service provider, and we'll talk a little bit about that in a moment. But what are we going to talk about today?
Okay, so the agenda today, we're going to run through the overall solution we built. It's a large multi-tenant cloud solution. We're going to talk about the concepts that we used to build that. We're going to talk about what worked well. So where the actual product met the marketing hype and the slides of what it was promised by the sales guys, what it delivered on for us. We're going to talk about what didn't quite match the sales promise and what we wish we used. So this is where, because we built this 18 months ago now, it's been building, there's been a lot of change in the technology. There's some technology now that's available that wasn't when we started. So we're going to talk about what we wished we were able to use when we started. And the last bit, what we had to build ourselves. This is the part that you're not going to get from anyone. You can't buy it off the shelf. You're going to have to go and build it yourself. So I'll hand over to Phil.
Cool. So what this session is we're going to jump around on a couple of topics. I want you to take away the bits that are useful to you. We're going to look at some technologies that you might have looked at before and talk about how they can be used in a different way. I'm going to give you some headlines about some issues you might face in some of the technologies you're looking at and hopefully save you a bit of time there. I assume you know what Hyper-V is and System Center and all those sorts of products. We're not going to dive into how these technologies work, just our implementation of those components. Now, some of this won't apply to the enterprise. This was built for a large service provider, but we're going to talk some of the bits and pieces that might help you thinking when you're going through these sorts of things. We're not going to do any of that lovely marketing fluff. So we'll keep it short and sharp. And we're not going to do any demos because I figure if Jeff Woolsey can't remember his password, I haven't got much chance in demonstrating a fully automated cloud. So let me talk about what we built. This was a full enterprise class solution that customers can come along and buy, Exchange, Link, and SharePoint. So they put an order in, we type in a couple of details about the target system, what their customer name is, what domain they want to call it, what their network IDs and IPs are, and it goes off and it builds all of that for us at the press of a button. This thing, when we press the go button, builds 72 virtual machines across data centers in a fully redundant enterprise class deployment. Now, of course, you can't just deploy Exchange, SharePoint, and Link. You have to deploy a whole heap of other bits and pieces. So we worked fairly heavily on doing that. And what we do is a dedicated instance for the customers. So this creates a domain and it installs Exchange just for that person. Now, this is a cloud-based service. So our key components here are that it must be elastic and the costs must be kept down low because we're trying to compete against things like Office 365, which are fairly cheap. And Microsoft can buy storage a little bit cheaper than we could. So I'm going to talk about some concepts here. We built the solution in such a way it was flexible to add data centers. In fact, for us to add a data center outside of dropping a whole heap of hardware, we just add one line in our database, which is a new site, and then we can automatically start provisioning customers into that environment. So in each data center, we deploy some hardware, we put hypervisor on top of it, and that gives us our virtual fabric. And then on top of that, we start monitoring it with Operations Manager, managing the virtual layer with VMM, and using Orchestrator, which is a very key component, and I'll talk about that in a bit of depth, and Configuration Manager to manage it. Now, all of those grouped together are what we call a management stamp. We can deploy multiple management stamps. For example, we have a management stamp in our production environment, we have a management stamp in our test, and we have a management stamp if we need to deploy a dedicated management component. For example, if we were going to deploy this to a large federal government, they say, hey, you can't share management. So we've got the ability to go and redeploy a new one of these management stamps and give complete segregation. Now, once we've got the management stamp controlling our virtual fabric, a new customer comes along and we deploy a set of servers in each data center for them. And that's what we call a customer stamp. And the idea of the customer stamp is we can deploy these, and this is where the term stamping comes from, is just bang them out every time we need a new one and keep on deploying time and time again in a similar type fashion. Now, that sounds easy, but if you think about these customer stamps have got 72 virtual machines as a starting point in them, and they grow past that, and we've got 30, 40, 100 customers in there, that adds up to a lot of systems. So you now need to start managing that concept of the customer stamp, and things like versioning and desired configuration of those stamps becomes quite interesting. So what was missing inside System Center? This is all built on System Center with Hyper-V, but there's bits and pieces that Microsoft aren't going to give you, and this is the hard bit. It's a component called the autopilot system. You may have heard it when they talk about Bing, and when they talk about 365 or Azure. And the autopilot system is where all your business logic lives. You know, how do I grow Exchange when it reaches X amount of users? When do I need to add new virtual machines? How do I work out if a virtual machine's broken and I need to replace it? So the autopilot system takes telemetry information from Operations Manager, from Virtual Machine Manager, wherever it needs to get it from, or it takes user-based input, such as a web page that says, hey, go and create a new customer, or someone runs a job to say, now enable SharePoint for this user. And it then spouts those actions back into the systems that actually do things for you. For us, most of that was inside Orchestrator, talking to a Virtual Machine Manager to get things done, along with a lot of PowerShell. So the autopilot system, it needs to provision the new services. When a customer says, hey, I want to come on board, it needs to go and say, we need this many machines, we need to provision the networks, we need to connect them all together and create those components. It needs to look at the desired configuration. Elasticity in the environment is where the actual service will grow. So we start off with deploying the service as if it was going to support one user. And when we start sticking workloads on top of it, and we monitor that, and when it gets past, an Exchange database will fill up, at that point, we'll come and add a new Exchange database and start start leveling those out across the different databases. It has to do some specific alert capabilities. And the key for this is to work closely with the operations team to work out what can we do to reduce the cost in the environment. So when ops go, we're spending all day going and fixing this network or going and restarting this service. We simply go into Operations Manager, find the alert and the trigger point for that, and then put that back into the autopilot system to say, hey, the service has got a problem, go and make some changes to it. And a big component for us was the maintenance tasks and scheduling. Because this service was aimed at 99.95 availability, one of the key components about that, we're going to have a small maintenance window. So we schedule maintenance for 2 hours on a Saturday night. Now in that window, we might have a whole heap of stuff to get done. So this autopilot system needs to weigh up how many changes it's got to make in that window and then work out what it can get done and push things off to different nights for us. So the key component there about the autopilot system and reducing that human interaction, that's about two things for the customer. One, time to market. So when they say, I need a new SharePoint database, we can go and get the provision to them quickly. The second part is it just reduces cost overall, because as soon as you have to pass information between people and systems, your time and your costs go up fairly significantly. So let's talk a little bit about the things that worked well from Microsoft. So we're going to dig down inside the pieces of software that sort of saved our bacon. So first of all, lots of stuff did work well, as desired. We'll talk about bits and pieces that didn't, but some things that I wanted to call out specifically that made our lives a lot easier. And the first one, server placement. Now, the server placement component from VMM sort of seems simple and you start to use it and helps you out every now and then. It's not until you really sort of need it to do big things for you that can actually make a difference. And one of the changes that we made to this is we deployed 2 clusters in each data center. So one cluster was for SQL only, and one cluster was for every other virtual machine. Anyone got any idea of why we might have done that? Licensing, yes. Because we're going to buy SQL per processor licenses, it's very expensive. So if we can now isolate our SQL systems to a single cluster, that's a big cost saving. And to do this, we actually dug into custom properties. Not something you'd actually use a lot of when you're doing a VMM implementation, but this worked quite well. Because in the custom properties, not only can you define your own custom properties, but you can then define rules around those custom properties for placement. And you can set guidance rules. For example, we'd like it to be placed over here. If you can follow the rule, that's great. If you can't, that's okay as well. But you can also enforce strict placement. And for us, we use strict placement to say only SQL systems can land on these cluster. And for that, what that gave us is we could now take any system that we're going to deploy and simply throw it at the cloud. We didn't have to worry about which of the clusters it was going to land on. Now you can take this to another level. You might have special deployment service that you can actually take advantage of for special types of systems because you've optimized the performance or the storage, and it will help make that placement easy for you. Virtual Machine Manager networks worked really well for us. I mean, for each of our stamps, we had a management network, a domain network, iSCSI, a public network, and a cluster network, which we use for clustering and for Exchange replication. Now, nice and simple. Most of you have got this sort of many networks in your environment, but when you've got one of these for every customer, and you've got 30, 40, 100 customers in here, your networking starts to become a bit of a nightmare. So for us, all we wanted to do was take a virtual machine, throw it on the cloud, and then have it automatically plug itself into the network. This is where we got to. We're really happy with the way this performed. And it's fairly simple. You just need to know a couple of components about Virtual Machine Manager networks. And it's worthwhile reading up and putting these together to help you in your environment. So there's just a few little concepts that you need to learn. And so it's okay. Microsoft have got a little cheat sheet to make this easy. So I've got that cheat sheet for you. All right. Yes, it does look complicated. If you read through it and work through it, you'll get the solution you want, and it will make networking ongoing a lot easier. So please spend some time looking at that. Bare metal deployment. We're adding new service to our environment, and we use Virtual Machine Manager to deploy that image, join it to clusters, and get things up and running with a hypervisor. And that worked really well for us. If you've ever done it, it's a nice, simple wizard. You simply go through, click, deploy physical computer, you type in the management IP address or a range, and it'll go off and send off the image to that environment for you. And you can go through this wizard and you can come back to show me the PowerShell script. It'll come back with a couple of lines of PowerShell and you can then start to automate it. But you're probably going to want to augment that a little bit. Just put a couple of things because you don't want a vanilla server, you want to change a few things. So our PowerShell script, we added a couple of lines and it sort of looked like this. Now that does look complex, but we were customizing the hell out of everything we were doing for our servers. But we were getting the solution we want, and the core of that was VMM bare metal deployment. Our orchestrator. If you've ever seen me present before, you've probably heard that I love Orchestrator because it's simple, easy to use, and you can do a lot of things for it, and it's one of the most underutilized tools in the System Center suite. Now, we use a lot of Orchestrator. Practically all of our autopilot system is written in Orchestrator. So a couple of things with that. You need to stay modular, and I'll talk about those bits and pieces in a second, and that gives you a lot of reuse. So we started off building this huge orchestrator library, and now when we find we're coming to do new tasks, we've got all of these components we can draw upon and make things happen really quickly. One thing we did work out, though, is we initially started out drawing out all of our information from the machines themselves, like going and reading the machine's IP address or going working out what type of machine that is and what we should do with it. We found out quickly that when you're building a system like this, it's a great idea to have a database to build all that off. And suddenly we're sounding like a piece of software, right? We've got a whole heap of code that does stuff and a database. Well, that's pretty much where you end up, but Orchestrator saves you a lot of time and a lot of that, bits and pieces. So what we fully automated, when I say fully automated, it deploys it, it installs it, it does the prereqs, it configures it, it turns it on and gets it running. And that's a big list. There's some things that are missing out of there, and I'll talk about those shortly. But I'm pretty impressed with the stuff we've done around SQL and the fact that we can do it mirrored or log shipped or always on and get things up and running. And the Exchange stuff too, they did a great job there. So you can get to this level of automation. You might not want to, it's probably going to be a lot quicker for you guys in most environments to go and install and configure these things yourselves. But in an environment where you do need to deploy it time and time again, Orchestrator can do that for you. So the modularity is an important component. And we started off with this concept and we adhered to them mostly. Sometimes you've got to break the rule. But the idea is in Orchestrator, you'll call sub-runbooks. So you start off with a level of runbook, which is your business process. And that calls your domain processes. The domain processes are basically a set of runbooks that run in a particular area. It could be Exchange, it could be network, it could be Windows Server. And the idea of having that grouping in there allows you to not only consolidate the bits and pieces or work out where your code's going, which is fairly important when you suddenly can't find one of the runbooks you're looking for, but also it allows you to snap in and out orchestration systems. So you might be using Orchestrator for Windows Server and for Exchange, and you might be using some other orchestration system to do your network components. If you keep to this environment, your domain runbooks tend to be different types of orchestration systems if you need to move them in and out. We did everything with Orchestrator itself, and it was great. And then you get down into your worker processes, and these are basically where the commands get run. So they are, give me some initialized data, run a command, return your data. So some things to think about when you're doing large sorts of orchestration. Orchestrator itself calls PowerShell 2. If you want to use PowerShell 3, you can use the VMM PowerShell call command, because that calls out to v3. Pick a standard for your error handling. For us, we simply returned out of every runbook error code and error summary, and we would pass that information back up. So we could then make intelligent decisions and recover from errors that were occurring inside sub-runbooks. The well-documented process for new orchestration routines. Because you're going to orchestrate so much, and this applies to pretty much any environment, everyone inside the company will want to use some sort of orchestration quite often. We've helped some people out doing orchestration on just checking log files and those components. And they had nothing to do with the IT guys, it was someone who had a business process. If you have a well-documented process on, hey, here's what I want to be orchestrated, and then you hand it off to your orchestration guys, they can churn through these things in a good fashion. And always include some validation steps in there too. Testing is big. Testing gets hard, especially when you start to talk about the monolithic components of Orchestrator, and I'll step into that in a little bit. So, what didn't work well? UAG and service templates, I'll talk about those in a minute. Microsoft best practice for sizing. So when we're deploying the stamp, and as I said, we initially deploy the stamp for one person, and then we grow as we need to. The link guy goes to me and goes, yeah, I just need 4 SQL servers. Yeah, no worries. I need 32 gig of RAM in each SQL server. You want 128 gig of RAM? Yeah, get stuffed. We started off with that, and then we tuned back to something that was a bit more realistic. Some of these things, we tuned them back too far. I think we tuned back Exchange in our test environment so far that stopped sending mail. The Exchange guys weren't happy. But start with there, but come back to what you really need to do. NIC teaming was problematic for us in 2 parts. First part is the type of equipment we were using had 2 different fabrics, and that when we team NICs down those 2 different fabrics, one information would pass out one fabric and come back in the other. A router in the middle was doing something funny to one type of packet when we used to set up Exchange DAGs, and we couldn't work out what that packet was, so we just had to stop routing out the other fabric. The other portion of NIC teaming that wasn't working well for us was some of the 2012 NIC teaming. When we started using native NIC teaming, we're having trouble forming guest clusters across from different hosts. And whilst we spent a bit of time with Microsoft trying to troubleshoot this, a 2-minute conversation with a certain principal program manager yesterday told me where it was, and it was in the cluster filter driver. Fibre attach. Fibre attach was going to solve a lot of things for us. When I say fibre attach, I mean virtual fibre attach. We'll talk about this in a little bit. But we couldn't do fibre attach because the drivers weren't ready. Something simple as an industry standard as MPIV wasn't implemented in the driver for the 2012 release. Version control and Orchestrator, I mentioned that a moment ago, the monolithic components of Orchestrator. The fact that there is no version control for runbooks. Now, if you've got a worker runbook down the bottom that simply says something like attach NIC or deploy virtual machine or run this PowerShell command, and you make one change to that, that changes right across your entire environment. And so suddenly, you've got to either regression test the whole lot or pray that it's not going to break too much. And the other component is, if you start to bring in different versions of those components from your test environment to your production environment, there's not a lot of capabilities to slot things in and out. So we ended up treating Orchestrator runbooks as a huge monolithic component and move it around in one chunk. Third-party virtual switches. We wanted to use these. These sounded cool. And we tried, but they did some things for us. They were a bit late to market. And at the end of the day, we found we could do everything inside the Hyper-V switch. So that was a great piece of work in the Hyper-V switch. Now, does anyone know what UAG stands for? No one? So, Unified Access Gateway. Yeah, pretty close, but that's what I thought it was at the start. What I actually worked out it stood for is unautomatable garbage. We couldn't do anything with it, right? We can install it, and then it would take someone 2 days to handcraft all the stuff that needs to go in the UAG. And that's true today. That when we deploy a new virtual machine that's going to have UAG on it, someone has to go in and type in the config for it. Now, we're actually getting off UAG, and we're going to look at the R2 capabilities of the Web App Access Proxy feature. We're just getting some more information around that, and also use that as a forward proxy as well. The link topology builder. All this thing does is spit out an XML file. And you can automate that. However, my link guys wouldn't let me automate that because Microsoft doesn't support when you play with that XML file. So whenever we want to change the link topology, someone has to go run the link topology builder and build the XML file, which we knew what the result was going to be anyway, just so we can have Microsoft support. Service templates. You're thinking, hey, you're deploying a cloud, you're deploying lots of the same things. This is service templates. This is easy. We've got this all worked out for you. Those who don't know service templates, you define a set of virtual machines. You define what their scalability and how elastic they are, and they grow in an environment like this. And then you can just automatically tier them up and tier them down. It's wonderful. It's perfect. It's exactly what you want. There's just one problem with that. When you deploy a service template, there's one thing in the middle, a network. You can't change that network and you're deploying the service template. You're stuck. So we could not use service templates. The other thing that service templates didn't do for us was allow us to scale up. They'll scale out, they'll tier the machines for you, but you can't suddenly go and start saying, hey, this Exchange server is running hot, let's go and shut it down and add some more processes to it and bring it back up, because now you're out of compliance with the service template and you can't reapply service template. So for us, we built the service template concept inside Orchestrator and in database. It wasn't too hard and allows us to obviously play with things a lot more ourselves. So I'll talk about some of the things that we wished we used. PVLANs. Who here is familiar with PVLANs? Wow. See, I knew nothing about them when I started doing them. Private virtual LANs allow you to have special types of ports that allow you to isolate people on the same subnet. So you can put multiple people on the same VLAN and they can't sort of see each other, which is great when you've got one set of management infrastructure that's talking to lots of different customers, but you don't want the customers to talk to each other. So we wanted to use PVLANs, the Hyper-V PVLAN capability, but the hardware provider we were on won't allow you to trunk PVLANs. And more to the point, when you define a PVLAN at the hardware layer, it'll rip off all tagging and stick its own PVLAN on it anyway. So Hyper-V could do nothing for us. What we had to do at the end was use IP filtering inside Hyper-V, so people attached to the same switch couldn't actually talk to each other, but then we tag it with the PVLAN at the hardware layer as it went out. Data Protection Manager, we were doing Exchange, SharePoint and Link. So Data Protection Manager is great at backing these things up. We prescribed our backup solution, but Data Protection Manager was a part of the System Center suite, so it would have made it cheap for us to use, but also it's something we can tier at the software layer and get some more expandability. Software load balancers.
Did you say SMB?
I'm going to cover SMB in a bit more detail in a second. I really wish we'd use SMB, but that's what we'll talk about in a bit more depth. Software load balancers. Again, in a cloud type environment, when we're deploying those customer stamps, what's great for us is if we could have deployed a software load balancer for each one of those customer stamps rather than using hardware load balancers that required a lot of manual config. Something to look at. There's quite a few vendors that are doing that. Replica's a cool technology. We want 99.95 availability, so replica seemed like a great idea to copy things between data centers for us. We couldn't find a use for it. Active Directory, Exchange, SharePoint, Link, SQL, all of those systems were doing application-based replication in a better fashion than we could using Replica. And the Windows Azure pack, sort of a bit late to the market for us. It's got some nice bits and pieces in it, and we're looking forward to playing with those components, but it would have shortcut a lot of the infrastructure as a service type capabilities that we built out ourselves. So with that, Toby, can you talk about how we were looking at attaching storage to guest systems?
Thanks, Phil. So in a large multi-tenant environment, storage is key. There's a big investment in storage. It's not cheap, so we need to make sure we're optimizing that storage. So when we have a large customer stamp and big data, it's going to get really expensive really quickly. if we're not able to move that around. The management overhead can become really expensive for us. When you have an Exchange server, it might be stood up for one customer and one mailbox, but that's going to grow over time, and the customer puts more information in there. They're not paying for the storage anywhere near what they were paying for local, so they just put more and more data up there. So we need to be able to scale that storage up to terabytes of information. You do the same thing for SQL, and suddenly you end up with this management nightmare where there's a lot of LUNs, a lot of complexity, and you're trying to just a full-time job managing your servers. We need to be able to rebalance these. So as we're building this cloud, we don't want to just buy hardware up front. We add in as we need the capacity. So we add in the hosts and add in clusters. You've got 16 host limit in each cluster, so we're adding more and more clusters, and it's growing all the time. How do we do that and allow us to load balance the machines across without moving the data all the time? If you've got terabytes of mail...
I'm so mean.
Oh, thanks, mate. If you've got terabytes of mail and we need to load balance, we don't want to have to move all of that data from one cluster over to the other, because copying that data across your network is going to take time. So dynamically adding and removing storage is something that we really wanted to do, and take advantage of some of the sand-based features that are there, the technology that the vendors are providing. So we'll be using iSCSI, but we wanted to have a look at some of the other technology. Virtual fibre channel. So in 2012, as Phil mentioned, you now have the ability to add a virtual fibre channel adapter into your guest. This solves a lot of problems for us, because it means we're no longer dependent on attaching the storage just to the host. We can attach directly to the guest and get hardware level connectivity from our guest virtual machine directly to the SAN, taking advantage of the hardware providers, the snapshot providers, and the technology that's there. The consideration with using virtual fibre channel adapters is when you're looking at live migration. To do this, you need 2 WWN set names. And the way that works is as you're live migrating a virtual machine, having the 2 WWN sets means that the connectivity is maintained. Hyper-V automatically manages connectivity between the two sets. The issue that we came up with, as Phil mentioned, when we started out, the drivers were late to market for 2012, so we didn't have any option of using the virtual fibre channel adapter. The host drivers didn't support the PVLANs and what we needed to use here, MPIV. So the host fibre channel adapter driver didn't support MPIV. And then as we started looking at, again lately, there's still a 128 limit on WWN sets for each adapter. So when you're talking about a guest virtual machine, having 2, and then 4 if you want multipathing, the scalability there, you're left with 32 guests per adapter on the host. Now, when we're talking about consolidating SQL and trying to reduce licensing costs, it means we need to add more adapters in. So this is something that we're definitely watching and looking at implementing in a future release. SMB file share is another one that's really interesting for us. Going back to my point before, moving data around the data center with terabytes of information and lots of customer stamps and dynamically moving and balancing becomes complex if you have to move that data. Before 2012, we had the limitation where the data could only be shared within the cluster. So you use the CSV and you can move between hosts, but you're limited by that cluster. SMB file share allows us to put all of that data onto the network storage. And now we just make a connectivity from the host over to the target host, and we just move the configuration and then the memory. We're not moving those terabytes of data that the customer has, so we can move really quickly outside of that limitation of the cluster. We can move between other environments. It means faster migration. We can do simultaneous migration, and it gives us a lot more flexibility. So this is something that we wish we'd use. Too many animations, sorry. When you combine that with the shared virtual disk, this is where it becomes interesting for us. In a customer stamp, as Phil mentioned, we have redundancy built into there, so we're using guest-based clustering. With guest-based clustering, you need to attach storage for that cluster shared disk. And the issue that we had there is that the storage management becomes very complex. With 8 to 10 clusters in each customer stamp, 8 to 10 LUNs, before we start installing Exchange or SQL or any of the capacity there, just to enable clustering. The shared virtual disk means that we can now do that without getting the storage guys involved. We can just ask for a chunk of storage, we create the shared virtual disks, and we can manage it and set that up without any involvement. It's a lot easier, so it is something that we're keen to look at.
Cool. Thanks for that, Toby. So they sound like really interesting components. We're going to evaluate both of those and haven't started down that path at this stage. But I'm interested in getting, your opinions on this. So I thought we'd just pick someone randomly from the audience to come up and have a chat about what they think about these components. So with that, is there anyone in the audience that roughly looks like this? You, sir, in this wildly unrehearsed random moment.
Random moment. I also conveniently happen to have a microphone.
So for those of you who don't know, Ben, Principal Project Manager, Program Manager for Virtual PC on Mac. You turned yourself off again.
I've turned myself off. There, now I'm on.
Cool. So you've obviously got opinion about some of these technologies and where they're going.
Funnily enough, yes.
Cool. Can you enlighten us a little bit on what you think about comparison?
So there's a really interesting discussion to have around virtual fiber channel versus the shared VHDX as you're planning and thinking about deployments. Now, from the Hyper-V side of things, when we started looking at virtual fiber channel and then onto the shared VHDX, we really had one top goal, and that was we wanted to be able to virtualize every workload. And when we're out talking to people and saying, what are the workloads that you're not virtualizing, the answer that we heard over and over again was, we can't virtualize that SQL cluster. And that's actually what encouraged us to look into doing the virtual fiber channel support. The other reason why we looked at virtual fiber channel was we knew that a lot of customers had existing investments in fiber channel and they wanted to take advantage of that. But honestly, where we are today, for people who are looking at new deployments, every time I would recommend using shared VHD on SMB over virtual fiber channel. Certainly if you have fiber channel in your environment, fine, go ahead and use it. I'm not going to tell you to rip it out. That's an investment that you've already made. But if you start looking into the shared VHD over virtual fiber channel, the first thing to be really clear on is from a performance point of view, from a capability point of view, from an enterprise grade clustering point of view, it's all the same. But with the shared VHD, first, as these guys identified, getting NPIV working in your environment is quite problematic. It takes research, it takes so on. Getting SMB working in your environment, I think most of us have pulled that off already. I think that one's down. The next one is how many people here have had experience with configuring MPIO on fiber channel in their environment? It's not simple, is it? It took some work. If you've installed Windows Server 2012 on a computer, you have already configured MPIO for SMB. It just works. There is no configuration, so that's a big win. And the final thing, and this is what Toby was talking about, is that yes, once you move to shared VHDX, you're no longer having to do LUN management. You're no longer having to get involved in the storage. You're able to just have a single SMB share, VHDs on there, and the management and flexibility is a lot easier. So,
cool. Unrehearsed question for you, which will put you on the spot.
I do hope you guys look at that and let us know how it goes.
Would you recommend a dedicated network for the SMB share?
That is an unrehearsed question.
It is.
Would I recommend a dedicated network for the SMB share? That is actually quite a tricky question to answer. It's actually going to depend on your infrastructure. So the key thing to consider here is whether you're going to be investing in RDMA capable network adapters. So RDMA, really cool as far as I'm concerned. It's black magic. It gives you amazing performance. However, a trade-off that not many people are aware of is that right now we don't have, and when I say we, I mean the entire industry, do not have a great cost story around RDMA. So if you were looking at an environment without RDMA, you've just got a bunch of 10 gig NICs not using RDMA, then I would say converge your networks. Simplify, converge your networks, get in there, use QoS, use virtual networks to carve that up. That's going to be your best option. However, if you're going to be looking at investing into RDMA, then unfortunately today you're probably going to have a separate network for your storage, just because, as I said, the industry doesn't have a great QoS story for RDMA today.
Cool. So while we go up here, I might just ask you a couple other quick questions, because you helped us out a little bit when we were doing some of this deployment work. And one of the questions I talked to you about was hyperthreading, because if you read the Exchange guidance, it says, turn off hyperthreading. All the Exchange guys ran up to me and said, we've got to turn off hyperthreading. And I'm like, I don't want to lose half my processors.
So this is an interesting area. Now, I've been working in virtualization and server software for over 10 years now. And working on the virtualization team, I actually have become all too familiar with the evolution of the Intel chipset and the platform. Now, for those of you who were around at the time when the original hyperthreading came out, you probably are familiar with, Intel introduced hyperthreading with the Pentium 4 chipset, came out, made a big splash and hurrah, and a couple of months later, the server world woke up and realized that actually there were many cases where having hyperthreading on would actually degrade your overall performance. And there was a whole bunch of effort. We had a whole wave of having to say, if you're running this workload, if you're running that workload, turn hyperthreading off, turn hyperthreading off. We actually, going in the Wayback Machine, in Virtual Server 2005 R2, we actually did a bunch of work to make it so that we could run on a system with hyperthreading enabled, and we were aware of it, and we were really cautious about it, so you could have it turned on and it wouldn't be a problem. Now, an interesting thing has happened in the hardware since then. So we had the hyperthreading in the Pentium 4, and it was a bad implementation. Intel learned a lesson. Their next generation of processors, the Centrino processors, did not have hyperthreading at all. They backed away completely. They actually went back to the drawing board. And when they reintroduced hyperthreading, even though they used the same names, it's a very different thing in the hardware. So we've discovered through extensive profiling that these days, modern processors, you don't have this issue of if you turn hyperthreading on, you could potentially lose. Now that said, from a Hyper-V point of view, it's really 6 of one, half a dozen of the other. Because while it's true that we don't have this issue of hyperthreading on fully loaded performance loss, that doesn't happen. And while it's true that when you turn hyperthreading on, like, hey, you just doubled your number of processors, from a Hyper-V perspective, you also have the capacity of those processors. And we happen to be very good at multiplexing virtual processors on physical processors. So from our point of view, we don't care. Do whatever you want. The performance you're going to get out of the system, whether you have hyperthreading on or off with Hyper-V, is going to be completely the same. Now, one nice thing is that once you have Hyper-V on there, any software running inside the virtual machine doesn't even know if hyperthreading is turned on or off at the physical layer.
Cool, so we'll hide it from the Exchange guys, they won't know.
Yeah, absolutely. And honestly, when I talk to most operations guys, the pain of having to go in and change a BIOS setting on 100 servers in a data center, just leave it the way it is. If it's on, great. If it's off, great. It's all good.
Cool. An interesting topic, we talked a little bit about TimeSync. Now, a while ago you wrote a blog post, great blog post, talked about how TimeSync works, said leave TimeSync on and everything. And later on, there's been a KB article coming out saying turn it off on your domain controllers. Can you explain to us why they're wrong?
So the reality here is, and I've had extensive discussions, I honestly think when it comes to the topic of time synchronization, we don't need a blog post or a KB article, we need a book. Because the real answer here is, whether you're doing virtualization or not, you need to understand how time synchronization flows through your system. You need to be able to, draw a graph and show that you have authoritative time coming from a trusted source and that it is flowing correctly through your system. That's like whether you've got virtual machines or physical computers. And unfortunately, one of the challenges we hit is, depending on your deployment, where authoritative time comes from and how it flows through the system is going to change. Now, virtual machines do add a couple of interesting wrinkles here. The first one to be aware of, and this is where we get into a lot of debates and tussles back and forward, is time in virtual machines will always have a tendency to drift. Now, unfortunately, how much it drifts, I was chatting to Phil about this last night, and I was saying, honestly, I think every release, someone on the Hyper-V team goes and fiddles with time tracking inside of a virtual machine to try and make it a little bit better. And sometimes they succeed, and sometimes they make things worse, and sometimes we look at what they've done, and we say, no way that's going in the code, go throw that out. And I've lost track of the number of times. I've been working in virtualization for 10 years now. I've lost track of the number of times that I've had a release where I've thought yeah, we finally nailed time. It's now reliable. And 3 months later, I'm talking to a customer and they're telling me in my configuration, time's drifting. So that is something that you just need to account for. You need to make sure that you're keeping an eye on that, and you need to make sure that you're managing that correctly. The second thing that comes up is we do have our time synchronization integration component, which we built to help with the time drift issue. And in most cases, it's good. All it's doing is it's grabbing the time from the physical computer and feeding it into the virtual machine repeatedly and going, here's the time, here's the time, here's the time, here's the time. The problem we have with that is when people do not sit down and think through what's the authoritative flow of time through our system, it can create a loop. And that's the end of the world. Because the bad scenario is if you have a domain controller in a VM and the physical computer is joined to the domain and it's viewing that domain controller as its authoritative time source, and we have the integration component completing the loop. That will cause time to drift at amazing speeds. And now we're not talking about drift, we're talking swept away in the current. The final thing, just an interesting note, this is something that we changed in 2012. An interesting challenge that we had with time in 2008, or two that we've now changed in 2012, is, I mentioned, we grab the time from the parent, the host, and we feed it into the virtual machine. Well, hopefully you're familiar with, you have a PC, it tracks time, you turn your PC off, and there's actually a little battery on the motherboard that runs a clock and just keeps counting time so that when you turn the PC back on, it goes 3 hours has passed, here's the time. Feeds it into the BIOS, and that's what the operating system gets. Well, with virtual machines, you turn the virtual machine off and it's gone. There isn't a battery, there isn't a clock or anything. So what we do is when you turn the virtual machine on, we just grab the time from the host and we feed it into the virtual machine and go, that's the time in the BIOS. And that works really well unless you have virtual machines that are running in different time zones than the host. And this is where we've seen some really gnarly stuff come up. Now, BIOS does not have a concept of time zones. And what, time zone is a concept that's implemented by Windows once it's booted up. And we've seen some really, there's some really interesting race conditions. When I say interesting, I mean bad. Where, if you're running virtual machines in a different time zone, they'll boot up, they'll get a time that's 7 hours off. And this actually happens at about 50% of the time, 50% of the time synchronization stack comes up first in Windows and you're good. 50% of the time, the DHCP client comes up first and you don't get an IP address. Because halfway through DHCP negotiation, the time sync comes up and we go, 7 hours. And things fall apart. So in 2012, we actually made a specific change to address the different time zone issue, where now, if we see the guest operating system set the clock, which happens when you change the time zone. So if we see the guest operating system say, oh, by the way, time is now 7 p.m., we calculate, hey, wait a second, what's the skew between that and time currently in the host? And we record that in the virtual machine configuration file. Next time it powers on, we apply that skew so that it's maintained. Now, unfortunately, getting back to your original question, what's the guidance on turning the time sync integration component on or off? It's not clear. It really does depend on how your environment is designed and how time is flowing through your environment. Personally, my preference is that you should have the integration component turned on whenever possible. It's there for a reason. It really helps with time drift. But you have to be very aware to watch out for the potential loops in your time synchronization flow. And if you have a potential for one of those, that's when you need to go turn the integration component off.
Cool, thanks for that. Mental note, give Ben yes or no answer questions.
Yes.
So 2012, you changed a lot of stuff,
yes.
right? And you heard about some of the problems that we had around drivers. And I'm sure we weren't the only ones. Now, the new one coming out, you've called R2, right? So that means there's no kernel changes or anything like that, doesn't it?
No,
means we're not going to have driver issues. It'll all be good, won't it? We've fixed all the 2012 stuff. R2 drivers.
Drivers are always perfect.
Cool.
You want a yes/no answer? So kind of coming back to the MPIV conversation, and we've actually been having a similar conversation with people around stuff like the ODX technology that we've added support for. Let's do a show of hands here. How many people get a bit uncomfortable if they hear the phrase network offload? Yeah. Okay. Most of us have had this experience, as server admins. We understand what network offloads are. They're when, we take advantage of hardware acceleration in the network adapter to get you better performance. But most of us have been burnt at one time or another by a network adapter which frankly had a crappy implementation of a network offload. And if I talk to people who've done multiple, private cloud deployments and say, hey, what would your advice be to someone about, dealing with network offloads? The answer that I hear time and time again is like, look, network offloads are critical to get the performance you want, but you need to test your hardware. You need to trust your hardware. You need to test your drivers. You need to trust your drivers. You need to make sure you have the same hardware, the same drivers. I've even had people go as far as saying, and you need to make sure that the same firmware is flashed on all of your network adapters, because I've talked to people who got burnt because they thought they had the same network adapters, but there were different firmwares. When you start looking at MPIV and ODX, these are storage offloads. It's really what it is. It is exactly the same scenario that we've had with networking now applied to storage. Yes, when it works, fantastic. But you are putting, the reliability of your storage system in the hands of your hardware vendor. So you need to do the testing. You need to do the validation. And I've already seen instances where, yes, we've had drivers for Fibre Channel where the MPIV was kind of flaky. I have seen, and I won't name names because I get in trouble if I do this, but I have seen SANs from certain vendors where their ODX implementation on firmware had significant issues, and we had to work with them to get firmware upgrades. So I met with a customer this week who was really excited about ODX, and I stopped him and I said, please, before you turn that on in your production system, set it up in a test dev environment and put some load on there and make sure it actually works reliably and well with your system.
So I heard blah, 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 no problems with drivers. That's
yeah,
great.
absolutely.
Thanks.
Rock solid. You can just turn it on and party.
Thanks for that. If you could stick around for a couple of questions afterwards, I'm sure there'll be a couple of follow-up bits and pieces. So let's just quickly talk about what we had to build ourselves in all of this, what Microsoft's not going to give you, what you can't go to a web page and download the code for. And the biggest one of that, which I talked about at the start, is this cloud autopilot system. The fact that you've got to build some business intelligence around this. Now with the Azure Pack, we're seeing some of those components start to come out. But overall, it's definitely not going to give you elasticity to start off with. Sure, you can do some tiering, but it's not going to tell you give you the business rules of how to add storage to your Exchange server to grow a database so you can start to grow out from there. You're going to have to work with your subject matter experts to get that sort of stuff and build it out. The job scheduling engine starts to become fairly complex in larger environments. So we've had to start building our own autopilot components for that. SQL deployment. Yes, you can do SQL deployment, you can sysprep SQL, but at the end of the day, a lot of the post-configuration, the mirroring, the log shipping, you're going to have to work hard on automating those bits and pieces as they build out. And orchestrator resilience is an interesting one. So basically, if you've got a very long runbook that might take half an hour to run through, if that crashes halfway through, the restart technology is fairly simplistic inside Orchestrator. So you need to build some intelligence in there in the fact that, hey, I knew this crashed for a reason. I want to start this runbook again at step 5. Now, you can build that in fairly simply with some starting parameters, but you need to put that in yourselves. So there's lots of related content. We haven't got anything specific in there. With that, I'd like to open up the floor to questions for myself, Ben, or Toby.